We have here on logistic equations, logistic growth is our second day of it. Our first video, we just went over what the shape of a logistic differential equation looks like. Went over loading capacity, just all the little parts of it. So for today, what we're going to do now is do more of the arithmetic involved with it and more of the calculus in terms of solving for it. So given the rate right here for the differential equation, we're going to go ahead and see what this thing actually looks like. Okay? So here we go. Got a question here about the flu. Rate at which the flu spreads through a community is modeled through the logistic differential equation dp over dt equals 0.001 p 3000 minus p. Okay? So this is already set up for us. Too bad this wasn't our coronavirus equation because the loaded capacity would only be 3,000. That'd be it. 3,000. But this is through a smaller community, so maybe the community's a little bit smaller. So if we have this initial condition right here, solve for p as a function of t, and let's show all work. So this is really what the meat and potatoes of this video is going ahead and solving for this equation. So I'm going to rewrite this real quick, but instead of the decimal version, I'm going to give you the version of the fraction. So I'm going to get dp over dt equals 1 over 1,000 p 3,000 minus p. Okay, so just like what you would do for solving a differential equation, get all of your variables on one side that relate to each other and all of the other variables on the other side. So these p's right here have to go with dp and move dt on the other side. So I'm going to get dp over, I'm dividing this p, 3,000 minus p, equals 1 over 1,000 dt. And what I'm going to do here is I'm going to have to take the integral. Now, I cannot necessarily take the integral of this one right here because I need to do a little work to it. There's no u sub, nothing simple like that. So I have to go and do some partial fractions. So with that being said, I have this 1 over p 3,000 minus p. I want to write this out as two separate fractions. Actually, that should be 3,000 minus p. Okay, so I want to do this work to the side over here. So essentially what's going to end up happening is I'm going to get 1 equals 3,000 minus p times a plus b times p. Okay, so if I'm looking at this, so for my, I'll show more work up here. Sorry, I'm kind of working a little bit in the backwards direction. So if I look at this for my p variables, I have 0 p's on the left. And on the right, I'm going to have a negative AP, so negative A, and then plus B. And then for my constants, I have 1 equals, it looks like it's just 3,000 A. Okay, so A is going to be 1 over 3,000. And solve for B in this case, so B is actually going to be the same thing. So I can go ahead and use this side work and rewrite this integral as, well, they're going to have a GCF, right? I'm going to have a GCF of 1 over 3,000, so I'm going to take out the 1 over 3,000 integral, because A and B are both 1 over 3,000, so I'm taking out that GCF, so I'm left with just 1 over p plus 1 over 3,000 minus p, and this is all dp, equals 1 over 1,000 dt. Okay? So now I can do the integrals of these separately. Actually, real quick before I even do that, multiply both sides by 3,000. That way that 1 over 3,000 is kind of out of my hair. And on this side, you're just going to get 3 dt. All right. Oh, I kind of made that look like a b, but that's the integral of 3 dt. Things happen. So here we go. Take the integral of the left-hand side. It's going to be ln of p plus, and we got to be careful on this one. we're going to do a little bit of a mini U sub. So if we do a mini U sub, you're actually going to end up getting a negative ln of this because it's a negative on the inside. So just kind of a mini U sub. I'm doing it mentally, but if you do a U sub there, you're going to actually have to pull out a negative value. So I'll put that in parentheses, distribute that, and this is going to be 3t plus our C value. Okay, so this is really ln of p minus ln of 3000 minus p equals 3t plus c. Now I'm going to use my log rules and combine these into just one ln. So it's ln of p over 3000 minus p. Okay, I'm going to go ahead and put that in absolute values. And this is going to equal 3t plus c. So we can go ahead and solve for, get rid of the ln right now. It does not matter because the absolute value is actually not going to come into play because we're not going to get a negative value. So since I do have this initial condition right here to solve for c, I can plug in a 0 for t, plug in a 50 for p, and then solve for c that way. Okay. So what I'm going to get here is plugging in that initial condition. I'm going to get ln of 50 over 3000 minus 50 equals 3 times 0, which is 0. So it equals c. So this is really going to reduce down to ln of 1 over 59, and that's going to equal my c value. All right, so coming back up here. This equation now, I have not solved for p yet, but I do have my c value. So ln of p over 3000 minus p equals 3t plus ln 1 over 59. Ooh, doggy. We didn't even solve for p yet. So how are we going to do that? How do you solve for p? You raise everything to the e. So raise this entire thing to the e and raise this entire thing to the e. So when we do that, let's kind of do that in red. So this is like e to the all that, and this is e to the all that. What's going to end up happening here is this is going to cancel out, and I'm left with just p over 3000 minus p. This is going to equal e to the 3t plus ln of 1 over 59. So I can clean this up. This is really a plus. This is really going to be the same thing as e to the 3t times e to the ln of 1 over 59. And that e to the ln is going to actually end up canceling out. So I'm left with this. Okay. Just trying to see where we're at right now. Okay. All right, let's go ahead and cross multiply here. So I'm going to end up with, oh, I forgot my minus p. I was like, that looked way too easy. Okay, sorry. So I'm going to go ahead and cross multiply now. So I'm going to get 59p equals 3000 minus p e to the 3t. So I'm going to get 59p distribute 3000 e to the 3t minus p e to the 3t. Yeah, and then I'm going to move this over here. Just make sure there's nothing like weird, no weird tricks. This is pretty straightforward. Okay, so move this negative p e to the 3t over here so that all of my p's are on the same side. And then you're going to take our GCF of a p. So you're going to get 59 plus e to the 3t equals 3000 e to the 3t. So now finally, woo, you're going to get 3000. You divide that over e to the 3t all over 59 plus e to the 3t. And that's it. So yeah, this differential equation, it's big. All right, so call this steps it took. There is a shortcut, and I'll get to that on the second page of the notes. So this is all part A, by the way. This is all part A. let's go ahead and get to part B now. So I solved for P, perfect. So use your solution A in your graphing calculator to find the size of the population when T is 2. So I'll show you what this graph looks like, of course. So I go to my y equals, and I'm going to go ahead and graph this. So I'm going to make that into a fraction. So it's going to be 3,000 e to the 3, no t, but x. And then down here, I'm going to have 59 plus e to the 3x. And let's just see what this thing looks like. I'm going to use my table real quick to kind of see like how big I have to get and how fast. Okay, so obviously it says it's going to be 3,000. It's just approaching 3,000 a lot, and I just noticed that this is very blurry. And that didn't help at all. Just go with it. So if I make my window, it looks like I can do 1 through 10, and I'm going to be good to go. So not 1 through 10, 0 to 10. And for my y minimum, I'll still get a -10, not a big deal, but I know my largest value is going to be 3,000. My y scale, I'll just make that 500. You don't really need to change that, but I kind of like that, looks nicer. So here's my logistic equation, and it's just going to kind of sit up there at 3,000 for quite a while. So you can see it's exponential, and then it's got its inflection point somewhere right around there. And there we go. So you need to find t equals 2. So all you're going to do is plug in a 2. So p of 2 is equal to 3,000 e to the 3 times 2 all over 59 plus e to the 3 times 2. 2 ways to do it. Since I'm already on this graphing page, if I hit this trace button, it wants me to pick an x value, and I can just press that, and then kablamo, it will give me this answer right down there, which is super blurry for you, but hey, I'll just tell you what it is. It is 2,617 people, because we don't round people up. We just truncate people. Sorry, that's what we do. Okay. And then for part C, and actually, if you want to know another way to do it, if you get it off of the graph, if you just pull up y1 parentheses 2, you get the exact same thing. Okay, well, this version is a little bit bigger because it's not so blurry. And then part C, use your solution and your graphing calculator to find the number of days that have passed when 2,400 people have contracted the flu. So now we're going to do 2,400 equals this graph. I'll just say P of T, so I have to write it all over again. So all you're going to do is go to your y equals, type this number in, graph it, find the intersection. That's all we're doing. So second trace, choice 5 is intersect. Just approach the intersection. If you hit second over, it goes a lot faster. So close enough to enter, second curve, enter, enter, and you're going to get t to equal, in this case, 1.821 days. Right? So that problem, yeah, that was I want to say a mouthful, but that was a good amount. Okay, so here's a shortcut. Okay, so I like this way, believe it or not, because all of these logistic growth problems go with the same pattern. Okay, like your A and your B value is always 1 over your loading capacity whenever you do your partial fractions. So it all kind of matches up. Okay, but there is a little bit of a shortcut here. So this is your logistic equation. P is equal to this. It's the L over 1 plus A e to the negative K LT, where A is equal to loaded capacity minus the initial. So granted, this may not look exactly the same as this answer right here, if you notice, but this is just a different form, and these could actually match up if we make them match up. Because if you notice, this is a 1 plus, and that's a 59 plus, and this is a negative value, and that's a positive value on the bottom. So there is a way to make this all look nice and pretty. So given this equation, let's go ahead and just use the formula. Some people like to use the formula. By some people, I mean 90% of the students I know use this formula for these logistic growth problems, and they like it. They're just like, oh, just memorize it. I don't ever memorize it because I rather just do the work. I kind of memorize what the steps include. So to find P, I first have to find A. So the loading capacity is 3,000. minus the initial amount, which we said is 50. And this is going to give me 59. Okay, so P is equal to my loading capacity all over 1 plus 59 e to the negative k. So k right here is going to be negative 0.001. And then L, loading capacity, so times 3,000. This is a time sign. I know this is still blurry. What the heck? That's better. This is a time sign right here. T? Yeah. Okay. So, yeah, let's simplify this a little bit. This is going to be 3,000 all over 1 plus 59. I'll multiply that. That's going to be negative 3, so e to the negative 3t. If you notice that these are actually going to be the same thing. If you multiply top and bottom by e to the 3t, you're actually going to get these answers going to match up. Okay, so same thing, just shortcut. AP accepts both those answers, FYI. So there you go. There is your logistic growth day 2. So now you know how to solve for them. So exciting.